Hi students, how are you? I hope you are doing well and safe at home. How was your exam? Was it easy? Yes. So today we are going to discuss our second chapter, acids, bases and salts. You have learned in your previous classes that the sour substances are called acids and the substances having bitter taste are called bases. And see, the sour taste or the bitter taste in each substance is due to the presence of acids or bases present in them. So let us discuss the properties of acids, bases and salts in this chapter in detail. Are you ready? Yes. So, first one, acids. Then can you say the properties of acids that you have studied in your previous classes? Yeah, first one, they have sour taste. Sour taste. And what about the color change on litmus paper? Litmus paper, yeah, that is, it turns blue litmus to red. Blue litmus to red. Any other idea? Yeah, that one more thing I think. Which was that? It furnish H plus ions in solution. Okay. The only 3 points that you know about acids. They are sour in taste. It turns blue litmus to red litmus. It furnish H plus ions in solution. Then here, as we know, litmus paper and litmus solutions are there. Then really what is a litmus? Litmus, as we know, is a substance which is used to check whether a given substance is an acid or a base. And that substances are called as indicators. Indicator. So what's indicator? Indicators are the substances which are used to check whether a given compound is an acid or a base. How? By their color change or by their smell. And the indicators can be prepared naturally, and therefore indicators are natural indicators and synthetic also. A very good natural indicator is turmeric. And do you have an experience while eating, the stain of curry is falling on our white dress? There will be a yellow spot is there, no doubt. And during washing, that is by rubbing with soap, it turns to red. Did you notice? Yes. So what's that? Or what's the reason behind it? That's the chemistry here. What's the chemistry here? Turmeric is a natural indicator. So it gives red color with soap. Why? Soap is a base. So by adding more and more water, what will happen? Yeah, again the red color changes to yellow. That is, the concentration of soap solution, that is base, become less. And similarly, another natural indicator, can you say one more example? Shoe flower or hibiscus. Then some plants in the class of Thallophyta, like red cabbage leaves, turmeric, colored petals of some flowers like Hydrangea are examples. So these are examples for natural indicators. But in the laboratory, we are using synthetic indicators. The only synthetic indicators we are used as phenolphthalein and methyl orange. Phenolphthalein and methyl orange, the two synthetic indicators. Okay, then let us do an activity in order to study the chemical and physical properties. Generally here, the chemical properties of acids. Let us discuss the activity 2.1. Here we are asking to collect some acids like HCl, H2SO4, HNO3, acetic acid, sodium hydroxide, calcium hydroxide, potassium hydroxide, magnesium hydroxide, etc. in from the laboratory. Then put a drop of each of the above solutions on a watch glass and test with a drop of the following indicators as shown below. What change in color did you observe with red litmus, blue litmus, phenolphthalein and methyl orange solutions for each of the solutions taken? And tabulate the following observations. So here, let us tabulate. What's the first column? Sample solution. Sample solution. And what's second column? Red litmus solution. Red litmus solution. And what about third one? Blue litmus solution. And next one, phenolphthalein solution. Phenolphthalein. And methyl orange. The first one is HCl, hydrochloric acid. While noting the color of red litmus, what will happen? HCl is an acid. Red litmus, is there any change? No, no change here. But what about blue litmus? It turns red. And what is the color of HCl in phenolphthalein? In phenolphthalein, HCl is colorless. Colorless. having no color, and methyl orange is orange red. Orange red. So HCl. Similarly, in the case of H2SO4, red litmus no change. Here also the same one. Here also. Here also. And the last one given is acetic acid. CH3COOH. Acetic acid. Acetic acid, as we know, it is an organic acid synthesized from plants or animals, etc. But these are called mineral acids. Okay, so acetic acid is an organic acid, and then whatever is chemical nature, the same as that of HCl or H2SO4 chemically, but they are not strong as that of these acids. That is, they are known as weak acids. Okay, that we shall discuss later. So the same properties like the other acids do. Then next one, NaOH, sodium hydroxide. NaOH in the red litmus paper, it turns blue. And what about blue litmus? No change. And here in phenolphthalein, it turns to pink. In methyl orange, it is golden yellow. Golden yellow. So, NaOH is a base. Similarly, what about KOH? It is same as NaOH. Base shows pink color in phenolphthalein and golden yellow in methyl orange. Then what about ammonium hydroxide, NH4OH? Here also NH4OH shows the same chemical properties as that of NaOH and KOH, since it is a base. But as we know, like acids, in bases also there are strong and weak bases. So here ammonium hydroxide is a weak base, whereas NaOH and KOH are strong bases. Okay? Yes. And here these substances like red litmus, blue litmus, phenolphthalein and methyl orange, they give different colors for acids and bases. So here acids and bases are identified by the change in color of these substances. Am I right? Yes. So these substances are called indicators. So indicators are the substances that are used to check whether a given compound is an acid or a base by noting their color. Okay, that is what we call indicators. And here one more type of indicators that we discussed in the first time itself. What's that? By changing their color or their odor. O-D-O-U-R. Odor means smell. So other type of indicators which are used to check whether a given compound is an acid or a base, noting their smell or odor, are called olfactory indicators. Olfactory indicators. So what are olfactory indicators? That is the substances which are used to check whether a given compound is an acid or a base by noting their odor or smell. the textbook. There's an activity is given to find out the olfactory indicators. See, the activity 2.2 is take some finely chopped onions in a plastic bag along with some strips of clean cloths. Tie up the bag tightly and leave it overnight in the fridge. The cloth strips can now be used to test for acids and bases. The chopped onion just keep overnight in a fridge by covering with a wet cloth. Taking this wet cloth, after one day it will use as an olfactory indicator. Let us do this in our class. Okay, and take two of these cloth strips and check their odor. Keep them on a clean surface and put a few drops of dilute HCl and on one strip and few drops of dilute NaOH solution on the other. Rinse both cloth strips with water and again check their odor. Note your observations. That is smell changed. Why? Because chopped onion can be used as an olfactory indicators. Similarly, here another dilute vanilla essence and clove oil. Vanilla essence, check soda, and after that take some acids or bases, and after mixing an acid or a base with the vanilla essence, we can feel the change in smell. I think it is so easy to you if you are at home. Now you can do this experiment from home itself. How? As same like just some onion get chopped and keep in fridge overnight with a cloth, and just take vinegar or citric acid, lemon juice, etc., or soap solution or baking soda powder. Baking soda powder, similarly soap, etc., can act as a base, whereas vinegar, lemon juice, etc., can act as acid. So this experiment, activity 2.2, is easy to do from home itself more than in the classroom. Okay, so you have to do and find out the change in smell. So here the chopped onion, vanilla essence, clove oil, etc. change their smell while adding acids or bases to it. So these are called olfactory indicators. Okay, olfactory indicators. So today we discussed what are acids and how can we identify whether a given compound is an acid or a base by changing their color and also their smell. Indicators are of two types, natural indicators and synthetic indicators, and they give different colors with acids or base. Okay, and olfactory also, that is they give different smell with acid or a base. Okay students, I hope the topic is easy for you. Okay, thank you.